just didn't want to pick and choose the problems for you, because they're all good problems.
I was doing them in order because I wasn't sure if I wrote it down, but there was
Yeah.
one with like flowcharts, and that was like.
All right. So, is there a reason we're now making a 4 group? Honestly, we can make 5, 6. We can push desks, move things, whatever. First things first, the lighting. I am trying this with my 7th graders because sometimes they're a bit too on, and this helps people be a bit calmer. It also helps your eyes to not get so tired because fluorescent lights actually make your eyes tired. And some of my students were complaining about like the day being long, and by the time they reach a certain point, they're really tired. And I think a lot of it is like you're looking at screens a lot, you're sitting under fluorescent lights, the air in here is often kind of dry. So I think I'm going to potentially get, what? That's just to move air around because our HVAC system is not great. Yeah, I mean, but it would replace, it would cost a lot of money to replace things like that. So I'm just trying to
not physically. Like use a blue light filter.
Oh, those.
I don't think I can on the projector. Maybe, okay. Yeah, I know I do it on my cell phone, but I don't know how to do it on a computer. So let's talk tomorrow real quick. Your homework for the rest of the week is already up on the board over there. 7th grade has Outsiders Day on Friday, but we still have class. So, because I think Friday is normal for you guys aside from the cookout. So we will at least be starting our assessment on Friday, so there will not be new homework. And 2, 3, 4 is the last lesson in the chapter. So if you are a worker or a header and want to go ahead and write all those things down, tomorrow's 233, 103 to 108, and Thursday's 234, like 114 to 119, I believe. Today we're doing more with triangle similarity, and I will caution you, it's very easy to think that things are similar or congruent and not double check ourselves, right? So if you are going to try to make a claim of yes, it is, or no, it isn't, make sure that you know how to support that one way or the other. This says use a flowchart, but we do not have to, right? Hopefully we all understand how a flowchart works. We're going to use whatever method we want. So as groups, as pairs, as individuals, I don't really care how you work. We're missing Satya today. Hi, Satya. Sorry you're not here. We are going to work through these 3 sets for our first problem here and determine if we think those are congruent. If so, we have to be able to cite how. Okay? So, dive in. What do you think? Are they congruent or not, and how? Talk with your group for it. Like, I'm not looking for answers right now. We're going to like work through them on your own or pairs or group or whatever, then we'll come back together.
Okay. It's just a dilation. There might not be enough. One angle is the same. One angle. The other similar.
If 2 angles are the same, the third angle has to be the same.
Oh yeah, they do. So they share the same.
The one is the same, and the other 2 are
So then the
the
other angle has to be the same because they're corresponding. And then that means the last thing is all 3 of them.
No,
Because like here,
M would be similar to M.
you want
A would be similar to M as an angle. And then
Now, A actually relates back to the most famous right triangle. The most famous right triangle is famous or popular, whatever you want to say, because it is the smallest right triangle we can make using integer values. The 3, 4, 5 right triangle. Now, this is actually used often to check squareness. And I did this with my brother's shed. If we're building something that we want to be square, if I measure 3 feet that way and 4 feet that way, and I've marked points there, the straight distance between them should be 5 feet. If it's not, you have to shift your square, like your sides, and until you get exactly 5 feet. And that's a really easy way in construction. So Mac Miller died. I don't know if you guys are aware of that, but I like Mac Miller, so I did not realize my ringtone was still on. But that's Party on Fifth Ave. We'll turn that off. Rest in peace, Mac Miller. All right. On that note, though, it appears that like Mac Miller had some mental health issues. If you need to talk with somebody, if you need help, like go seek that help. If Mac had like been forward about that and gotten some help, he probably would not have overdosed. Actually, I'm not sure exactly what he did. I'm not sure if it was technically an overdose or what exactly happened. I should read more into that. But 3, 4, 5 is the most famous right triangle, and any dilation of that, we can manipulate the knowledge of 3, 4, 5. So 9, 12, I see as times 3 times 3. Right? So this then has to be, and we could do Pythagorean theorem to check, it's got to be 15. The triangle IHG, what is that from the 3, 4, 5? It's just a times 4. So these are both dilations of your famous right triangle, or whatever you want to call it. Therefore, they are similar. Now, we could also set up the ratios of longest side compared to longest side, or shortest side compared to shortest side, or medium side to medium side, and check those out, which is what we can do in B. So if we set up some ratios, now, when you have all 3 sides, it's kind of easy, but always trying to investigate which is my biggest side, which is my smallest, and which is my middle. So if I look at biggest, right, 14 down to 7, what would our ratio be? 2. 2 to 1 or 1 to 2, depending on which way you go. Shortest side, 8 down to 4. My ratio hold? Yeah, it's good. Sweet. Great. They're similar, right?
No.
Check the third. And when we check the third, 9 and 5 do not have the ratio of 2, so these are not similar. Be careful. They set traps like that on purpose. Now, see, I heard some debating, and I think we all made it clear. Ooh, that's turned up really loud.
No, keep it like this.
No. So who can talk me through C? What you guys ended up figuring out? Chris?
They have marked out that those 2 angles are the same.
Okay.
Angle S and angle B, and they share angle M. So therefore, the angle T and angle N must be the same. And triangle angle.
So then we have angle, which is redundant. So we just say angle, and angle proves similarity. Thomas, is that the same thing you were going to say?
Yeah, except I did it a little bit differently. I just did B and S were similar, and they both are on the same line, so the TV and NS are parallel, so N and T.
Because of these angles being congruent, and this being one line, the other thing I want to make sure that we see is we can prove parallelness here by the corresponding angles. Because VM really becomes our transversal across those 2 lines, and they have to be parallel. So therefore, if we use TM as a different transversal, those angles are corresponding and have to be congruent. It all starts coming together, and it's pretty awesome when it does. All right. Using that same diagram, can we figure out these missing lengths? So challenge to you. Can we figure out JK? Can we figure out VT and TN? So, JK? Just kidding. We did it already, right? So we know that because it's a manipulation of the 3, 4, 5, we can easily... Now, if we didn't remember the 3, 4, 5, how would we figure it out? Pythagorean, right? Because it's a right triangle, we can always apply the Pythagorean. What about VT? Complications?
Yeah.
Well,
Oh,
wait,
no.
no.
You could do the outside thing where you like, since you know one's since 2.5 and 9 either side.
Oh, no, we can figure out exactly.
Oh, because the 11 down there, yeah.
If we had one more piece of information.
Yeah.
Because right now, we only have 2 pieces of information.
Well, we have 2.5, 9, and 11.
Well, okay, so we have 3, but does the 3 pieces of information relate to VT? No. So if we knew what this was, then we could totally solve VT. But with you guys saying, well, we do know MN or NM, can I solve TN? So I'll go ahead and say we can, with your group, figure out how we solve TM. Or TN, whichever, whether you want to do TM or TN, we can do either of them. So take a moment, write it, do the math. Do the math. So open up a page, shut your book that you're reading, because you won't have the opportunity to read that again. Well, like, not actively reading, but it is the book that you are reading.
Okay, so basically what you do is
Just take my book, you can like start reading your book, and then you lose your page.
Yes, that's what I'm doing.
I use a bookmark.
Richner, would you like a bookmark?
This works.
As soon as you sit down.
We'll look this in 15 minutes.
Hmm?
You're not getting this back.
I don't care if I have it.
We use them in work.
Now, you took the route where you used 2.5. Is there another route where you use a different number? So Thomas just showed me this. Now, in my brain, I would rather, now that'll work, but I would rather do 9 over 11.5 actually.
Yeah, but the total.
Because when we start working, thank you very much. Heard you left one of those outside.
Yeah, sorry.
It's all
I'm gonna
good.
steal some protractor.
Any of my stuff is yours for the taking, man. So the reason I would encourage you to set this up like this, we're relating the same side, right? Corresponding location, top or whatever you want to call it, short to long or small triangle to bigger triangle. So over here, we're going to have related the small triangle to the big triangle. The only reason I don't like using the 2.5 here is that's just like a little chunk. If I'm talking about entire triangles, I'd rather figure out the length of the whole triangle edge. Now, either way would get me there. So it's not like one of these is better. This is just how I do it. So if I set it up like this, I can cross multiply these values. If this was an easy ratio to figure out, I can just use that ratio here. But since it's not, I know that like 9x, or whatever we want to call it, is equal to 121 plus another 5.5. Sorry. Is it 126.5 maybe? So 11 times 11 would be 121.
Yeah.
Another half of 11 is another 5.5, right? So 126.5. Break up your multiplication.
Or you can do like 11 times 100, 11 times 10, 11 times 5, and boom, more.
Yeah. So 126.5 divided by 9. Anyone have a calculator?
No,
No.
You know it's what?
I know it would be.
Okay, what is it?
It would be
14
14 and 18.
14.0.
14 and 1/18.
For the entire side.
Yeah.
I'm not that.
So, yes.
Like 14.0.
So then Tn,
Yeah.
right, just the remaining.
Or well, 14.0, infinite 5, 5, 5, 5, 5, 5, 5, 5, 5.
Is it 0.0555 or infinite?
That would be 5.
14.05 repeating. 0.0
It's not 05050, is it?
0,
Yeah.
5.
So that is so weird. The 0.05 repeating. Never mind, we don't need to go deep into that because essentially at this point we're just using calculators to do this math. Realistically, and actually this is a debate that is ongoing. I'm kind of over here in the camp of why do we still teach what calculators do? Now the thought process behind how to do this, we should teach that thought process, but the actual like do this on paper, like you guys are going to have calculators.
We're going to have
All right.
calculators inside our brain.
Any questions on this?
Oh gosh. It's terrible until the last 10 pages. Not simply terrible.
All right, check this out. So Cameron offers a challenge. Cameron, maybe. Are the triangles at the right similar? If so, we have to explain how we know. Yeah, I'll leave it right there. So take a moment. How do we know?
Yeah, I know what you're saying.
So I agree with what Steven's saying. I don't know why they didn't put the little mark to show congruence, but if they have shown like, hey, that angle corresponds to that angle, yeah, they're relating that they're congruent.
So yeah, so if you flip it,
All right, so Steven, what can we then use to prove that the triangles are congruent? Side angle side, right? Because the angle's included, so you can use a little bit of sass here, and we can get side angle side, which then means we could make like if-then statements, right? So if these two triangles are congruent with each other, then PD would be congruent to ZY, or the then could be angle D congruent to angle Z, or the then could be like, we can make a lot of if-then statements and know a lot once we know that they're congruent. Or once they're similar, we can use that ratio instead of using that they're congruent.
Why not?
Maybe it's QDP, maybe it's not PD.
They have so much fun with like making little backwards words and making it confusing. Like on last night's homework, they had right equals false, but it's backwards.
Yeah. All right. So check these out. A little bit harder values, not the same. Hey, this actually takes your brain for a moment. Maybe just a moment. So check this out. Check what we know and what we don't know for sure, what we might know. Can we prove similarity here? We'll throw congruence out the window because we know that's not going to happen.
No.
wait.
So I've got both answers out there. We got to land on one. What? He said you did. Ask him.
I don't think we can. Because there's a range of numbers it could be. Just because those two are the same ratio doesn't mean that the other one has to be.
Okay, so then let Thomas rebuttal.
They have to, even because they're the same ratio and the angle is included is the same.
So what are you saying with same ratio? What do you mean by same ratio? What sides?
R whatever.
Actually,
RN is
CT.
similar to CT, and RU is similar to CA. And then R and C are similar.
Careful
What do we have? Side angle side. We don't have congruence, but we have the similarity ratio of 2 to 1. So, while I agree, if we didn't know anything else, there's a range of options for the third side, but we do know something else. We know the angle. And remember, hinge theorem locks us into saying if I know the length of the door and I know the length of the doorway, like, if this angle is the angle that it's fixed, this side has to be a certain length. Like hinge theorem tells us that. Now, if I didn't know the angle and the door could still open a different amount, then that's like we do have that range of possibilities. But that angle, and that's the tricky part. That was the trap door they were trying to get you to fall in. That angle is included to the sides that we have that similarity ratio. Any questions on that?
Nope.
Okay, dumb question. Are the triangles congruent?
No.
No. Dumber, well, not dumber.
Let's see.
Almost as dumb
Can
question.
we
Our
prove this?
similarity ratio is either. Okay, this is so easy. I think you're all like, why is he asking? Thomas? Yeah, either 2 to 1 or 1 to 2, right? Or you could honestly say 1/2 to 1 or weird things like that. But yeah, we either have double or half.
Think about it.
You're smart.
You're better than this.
Really, let's look at tomorrow's lesson. Because I kind of might make tomorrow more of a work day for us.
I can't tell it's a lesson.
So tomorrow, and I want to look at this today because we switched gears a little bit.
Lots of paper you can write the date the night before.
I'll raise you to the morning.
I can get it here.
I'll raise you to the class.
All right.
I'll raise you.
So I want to talk about things tomorrow that then you guys are gonna problem solve these things. And I don't want to do too much since Satya's not here, and I'm hoping he'll be back tomorrow. But tomorrow, you will not actually need a mirror, okay? Because we already did part of this activity earlier in the year. So you're gonna look at number 100, but you don't really need anything else except for the information given to you. So if we look at 101, the activity has us put a mirror on the floor, but we're not going to do that because we know what about how this mirror is going to work in this situation. What did we already talk about with reflection, right? Because mirrors reflect.
It's like
What is congruent?
Then the two angles.
the distance between them and the mirror.
No.
The person's face in the mirror is the same.
So, legend has it that if you stare into a person's eyes in a special way, you can hypnotize them to squawk like a chicken. Now, if you've ever been to the state fair or anywhere else, if you've ever been to the state fair or anywhere, apparently hypnotism is a thing.
It is real.
Which I'm not saying it's not a thing. I'm just arguing, is it a real thing? And then there's the idea that humans so badly want to be involved in something, like in groupthink or whatever else, like that you're not actually being hypnotized, but you are tricking yourself into believing that you are being hypnotized because you so badly want to be part of it. Like, there's all this theory.
You want to
So
be,
is that
you
why
want to be
hypnotism
hypnotized
is
because
only
you want it
supposed to
to be a
work if
thing.
you want it to work?
Supposedly. So I'm not going to give any definitive answers.
Somebody can't be like,
Okay, so
Josh.
So here's what we really need to do, and I might have us like measure most of us right now. If we're going to do this, and we know that those lie angles are the same, both the angle of descent and the angle of elevation, and we both know that we're standing perfectly straight up and down, 90-degree angles. The question becomes, if these triangles, instead of being congruent, are similar, right? So this will not be the same length as this. If one of you must stand 200 centimeters away from it, how far would the other person have to stand? So to know that, what other information are we going to need? Jacob?
Height of the person.
Yeah, this side, right? The height of the person. So if you do not know your height, like, 6 whatever, like, we're going to work in centimeters, so you have two options. We can either remeasure in centimeters, or if you know your height in, like, inches, we can convert. Right? So there's 2.54 centimeters for every inch is your conversion factor. So, hey, go ahead and get this down in your notes. 2.54 centimeters is 1 inch. That's our general conversion factor that we use. No, it does not line up that nice.
No, there's 10 millimeters in a centimeter.
Centimeter.
Not 10 centimeters.
Watch it!
2.54. If you need verification on Google, there it is. You don't trust your math teacher. Now, what I do love is Google has all these different measurements, so you can even go into nautical miles.
Do it.
Like, if I boat a nautical mile, how many feet have I actually boated?
A lot.
It's more than a regular mile because you're going on the water, right? So that and it's nautical miles are just awkward. Nanometers,
Yeah, they're really small.
really tiny.
Oh god. Yeah.
Why don't you put 3.28?
So if we look at how many inches it is, it's still to the negative 8th power.
Centimeters to millimeters.
Centimeter to nanometer.
Oh.
There are 10 million, right? Because that's 10 million,
Oh.
right? 1 times 10 to the 7th, because E is times 10 to the. Remember, E is times 10 to the. It's just shorthand way of saying the exponent of 10 is 7. So yeah, that's 10 million. All right, so I want to give you the rest of the time to work and or prep for tomorrow. If you don't know how tall you are, I have measuring tapes over there in the yellow bin. We can measure each other. Now, what you're going to want, hey, hold on. What you're going to want to do is get your measurement in just inches. So measuring tape should have a feet and inches marking and then also a just inches marking. Once you have that, we can put your inches in here and convert it to miles, or we can just do the math. So I am, depends on what we want to use as your, you can use your height where you are right now. You can lift yourself. Yeah, we can.
What is your favorite subject? I like it.
So I am 187 centimeters. If you want to use me as a reference tomorrow.
I'm 68 inches.
Okay, so 68. So you want to write this down, then you're 173 if we round.
70 inches.
70 inches.
Okay.
You're about
I would like
178.
to say that on this probability sheet it says certain for sure 100% the sun will come up tomorrow. That is not true.
Has there ever been a day where the sun didn't come up?
No, but at some point.
Based on experimental probability, that's 100%.
Well, then by that logic, I'm immortal.
Sure.
Because I have not died.
Well, yeah, based on experimental probability, your risk of death is 0.
64.
64.
68 and a half inches.
About 163 if you round, 162 and a half.
68 and a half.
Yeah, somebody help me out, please.
174 centimeters.
174. Wait, what do we got for Hunter over there?
You're asking.
53
53.
No, he was tilting it.
Hi, math is
It has to go directly up. No, you had it like this.
All right, how many?
The measuring tape's gotta be straight.
No, I already
52. 132.
Are you sure?
Who else?
I am 159.5.
Yeah, so it should be 151.
I'm tall.
So-
173 centimeters tall.
Hey, peeps, measuring your height is not this fun.
We make everything.
So we have about 10 minutes left. Hey, I need your attention. We have about 10 minutes left. If anyone else needs to know their centimeter conversion, let me know and I'll give it to you. Otherwise, you should start your homework and or start looking at the lesson for tomorrow. Hey, I want to be able to leave notes to the subs saying they know what to do. Don't worry about it. Okay? When you go through this lesson tomorrow, you want to choose a member or a couple. You can do it for different members of your team or different members of the class. You're going to have to know how tall they are versus how tall you are and set up those similar triangles based off that. Once you've done that a couple times to familiarize yourself, and of course that activity will be after the George Washington one, you are going to try to figure out the length of his nose. Yeah, no, we can do this. And then we can measure a building, actually, with indirect measurements. So this is going to lead us to a study later about how do we indirectly measure things. How do we use math instead of, like, I can't physically measure Big Ben.
But I'm sure someone's already
Yeah.
done it.
Lauren, is it you?
All right, so that's tomorrow. And it shouldn't really take you guys that long, so you should have time to work on your homework. My concern is you guys staying on task, right? Because you like to be goofy and have, like, side conversations and be off task. So, please stay on task, all right? Aside from that, take the next 8 to 10 minutes and work on your homework.
No promises, but